Hopefully you are seeing my screen right now, my first slide of my presentation. Yes?
Yes.
Okay.
We are seeing it.
So I'm very happy to be here. For the ones who are local, you might already know me. For the ones who are not local, I've been working with security for more than 15 years. The last 10, I decided to focus on application security and specifically on code protection, JavaScript security, and client security in general. This will be actually my sixth BSides conference, but it's a very special one because it's in Porto, my hometown, and it's the very first BSides at Porto. So thank you to the organization. Hopefully it will be the first of many. Also, anything related with browser security, reverse engineering, hacking the web in general, I'm very much interested in. As Gonzalo already said, I'm co-founder and CTO at JScrambler. And for today, I have a somewhat ambitious agenda, so I'll try to move quickly. First, I will frame what is MageCart, what are the MageCart attacks. Then we'll go through web skimming or web skimmer anatomy. Then we'll get into the main part of the presentation in which I'll present the work that we have been doing to catch web skimmers. If we have time, I'll present Brutus, that I'll talk about in a minute or so. And finally, the Q&A. So about MageCart attacks, some of you may have heard about MageCart. It actually, the name comes from Magento, the e-commerce software. Right now, it's no longer only related with Magento, it's actually affecting any e-commerce websites and even other types of websites, but mainly e-commerce. Anything that has payments or credit card payments information being inserted might be targeted by a MageCart attack. MageCart attack is part of a supply chain type of attacks. It usually targets third-party code that is...
Pedro, let me just interrupt you. On my screen, at least, I just see the first
all right, okay.
slide. So probably is not, or is not moving, or is swapped the screen.
Exactly. So let me fix that. Okay, so...
Sorry to cut your line of thought, but...
No. I'm glad you did. So let's see if this works. If this does not work, I will disconnect.
No, I think it's the same.
Multiple monitors. No, it's the same. All right. So yeah. No worries. I'll fix it. Just give it a second. And now I only have one monitor, so it must work. How about now?
Better.
It's okay?
Now. Okay.
Okay, all right. So, so like I was saying, usually targets third-party code that is used together in the web application, but in some cases it can also affect first-party code. The MageCart attacks are done initially by a single group, but eventually, as it became very profitable, many groups start doing the same, and now there's a whole cyber criminal area of people just going after the credit card information. It's no wonder it's popular because it scales well. If you manage to change a JavaScript file, you basically are able to inject arbitrary code in the page and do whatever you want, and it will affect all the users at once in that website. It's also popular because you don't have to affect the main website, the e-commerce shop. You can go after the weakest link, the third-party vendor that is being used in the page, and leverage the fact that they might have less resources dedicated to security, and it will be generally easier to compromise those third parties than going after the main website. So it basically works like this. You have third-party code being inserted dynamically into the page. That code can dynamically add more code. So there's a chaining effect. You can also have iframes, and those iframes can bring more JavaScript into the mix. If any of these are compromised, usually it means that the whole website is running injected arbitrary JavaScripts. Once he collects the data that he wants, it usually sends the data out, usually through XHR to a drop server running in some domain, in this case, coolestfonts.com, and the attacker is able to collect a large number of credit card data using this scheme. So you might ask, how big is this problem? How often this happens? Actually, right now, almost every week, certainly every month. And these are just a few that I was able to collect. It's somewhat hard to keep up and know about all of these attacks. It's becoming one of the most common type of attack out there right now. So let's get into the anatomy of a web skimmer. The web skimmer is the payload that gets delivered in a MageCart attack. This one that you're seeing is the payload for the Ticketmaster attack. So the attackers were able to compromise a third-party vendor called Inventa. And this is one line of code that has some obfuscation. It's actually not that sophisticated, so you can have a look at the unobfuscated version of that. It basically has this type of actions. First, it checks if it's in the correct page where the payment information is being inserted. Then it usually iterates all the form fields in the page, install event handlers to listen when clicks for clicks in these fields. When that happens, it collects all the data in those fields. It also installs event handler for on-submit events of the form. And eventually it sends data out to the drop server using XHR post, and it runs every 30 milliseconds in the page. So it's continuously trying to harvest information from the credit card form. Web skimmers are usually, so you can do a web skimmer by yourself, attackers can do it, but they usually buy a web skimmer kit. And they do it because then they don't need any special skills. They just need access to a compromised e-commerce server, a Magento, or anything else. They have access, and then they just inject the web skimmer in place. If you have a web skimmer kit, you'll have access to a C2 admin panel. You'll see the number of accesses and credit cards that were harvested. A web skimmer kit goes from $250 to $5,000 on the dark web. Usually it's used in spray and pray kind of attacks, so they will try to infect as many servers they can and try to be present in as many payment forms pages as they can. But this is not necessarily true for all attacks. Some attacks are very targeted. There are also toolkits like Inter. This is one example. Usually it goes, so it costs you $1,300. In this case, it uses a JavaScript obfuscator called Caesar Plus, which costs around $100 on the dark web. And one of the things that it does is fake checkout pages. So it takes the user through a fake checkout page, which is usually the type of attack that you see in a spray and pray kind of attack, because transactions are not successful. The ones that are more successful are the ones that are able to skim the credit card without interrupting the actual purchase, because then it will be harder for people to notice. So before I get into the solution that we are developing, let me very briefly talk about the type of protection that we are putting in place for this type of attacks. We have, so the talk is not about this at all. This is just a little bit of context. We have a solution where we have an embedded agent, which is inserted into web pages. And it uses JavaScript virtualization, which works like this. So the embedded agent is inserted. Then it proceeds to virtualizing, proxying a lot of DOM methods and web API methods. And once we do that, all the third-party code is basically running the proxy through the proxy versions of these methods, which means that we are doing a sort of man in the middle in the execution of these elements, methods, and we are able to enforce rules and to run policies. So what we do is we have a rule-based behavior control solution. It's meant to prevent magecart or form jacking, which is another term for credit card scheming. It checks for event-handler hijacking. It does DOM anti-tampering. It provides data leakage protection. And the embedded agent itself, it's protected with very advanced anti-tampering technology from JSGramma. So what we are talking next is something that is combined with this solution, but it's a separate piece. The motivation so what I'm talking about is the magecart classifier. The motivation for this is, of course, we can mitigate magecart, but by applying the rules and enforcing the rules. But sometimes it's hard to know that we are facing a schemer, that we are dealing with magecart, because there's lots of different codes out there, and they all might mess up with form fields and add their own event handlers and do a lot of different things. So how can we be sure that we are dealing with a schemer and what kind of schemer, and precisely what schemer are we talking about? So for that, we started working on a magecart classifier. Right now, it's a static code analysis based magecart classifier. And the goal is to answer this question. How likely is that this file contains a magecart schemer? And the answer is a percentage, 0 to 1. So first of all, a disclaimer, this is a work in progress. I'm presenting some results, but there's a lot of things to be done on top of what I'm presenting. So the requirements for the solution, we wanted the solution to be purely based on behavior, not regex expressions or any hard-coded signatures. There are some solutions in the market that use them, but it's far too easy for attackers to change those signatures and to break out from those regexes, because it's easy to transform JavaScript just enough so that those signatures are not triggering. So we are watching for behavior, what they are actually doing, what functions they are calling, rather than looking at the form as the main technique. It needs to deal with obfuscation, of course, because most of these schemers are obfuscated. So we need to detect obfuscation. We need to, in some cases, automatically deobfuscate the code in order to have a look at what's underneath. and to extract a diverse set of behaviors. And obviously, we want it to be as accurate as possible. The architecture in general is like this. So we have an obfuscation detection module. It detects if obfuscation is being used, but also what obfuscator was used. Then we have a deobfuscator module that's it's pretty self-explanatory what it does. And once we have the underlying code, we have a features extractor. So we are extracting the behaviors, the things that we're looking for using this module. And finally, we have a scorer module, which using heuristics and feature groups, it scores the file. And if the percentage is over 50%, we consider that to be a skimmer. So disclaimer, no AI is used. So I'm just anticipating this question, but we do have plans to use it in the future. For now is a simpler but effective first version of this MAGE card classifier. These are the groups of features that we are extracting, just examples. We look for many different dimensions, obfuscation, access to storage, the use of stenography, encoding techniques, network access, etc., etc. So the goal was to be as diverse as possible in order to better characterize the behavior of the web skimmers. So now let me, I'll demonstrate the use of the MAGE card classifier through the use of 3 skimmers samples. And first we'll start off with British Airways skimmer. So this skimmer is very simple. So you're seeing the 100% the skimmer on the right side window. It wasn't even obfuscated. It's just a simple function that hooks into the payment form and serializes all the form fields and sends everything to this baways.com server. I don't know if you know this, but this MAGE card attack was corresponded to the biggest GDPR fine in history. It was roughly 204 million euros of a fine. British Airways say that it ran for 15 days, but even that was controversial. Some people think that it lasted like 2 months. And they were able to scheme almost 400,000 credit cards. So the impact was huge. In terms of the skimmer, it uses no obfuscation and it does very simple things. So I'm running the MAGE card classifier. We have a demo. In order to save time, I pre-recorded the demo. So let me play this. I hope you can see. So it was inserted into a modernizer library at the very bottom of the script. Actually, it was a first-party breach. So someone from British Airways team fetched this file and it was already compromised. So it was a very severe incident. And next, I'll run the classifier. So the classifier is a CLI, a tool. It uses as input the file that we want to classify. And it also presents the features that we were able to find. Okay, so running this, it yields the final score. I'm not sure if you are able to see it, but it's 52%. All right. So just barely over the MAGE card threshold that we are considering because it doesn't use obfuscation. It's very simple. So regarding our heuristics, it barely is over the threshold that we consider. Nevertheless, we would have picked up this file and probably try to have a deeper look at it. Skimmer number 2 is the one that we saw before, the Ticketmaster Invent Skimmer. So this particular skimmer uses obfuscation. It also uses new techniques like page location check. It checks if it's in the right place. It has multi-page checkouts, so it uses cookies to store information as the user progresses in the payment process. And also the other things are the normal things that we have: event binding, XHR post, and target selectors. So we have new demo. So for this particular skimmer, we are testing 3 versions of the skimmer. The first one is an deobfuscated version of the skimmer. So after manual deobfuscation of the skimmer. And as you can see, the final score was 66%, and no obfuscation was detected in the features list because it's has been previously deobfuscated. But we also run for the obfuscated version, which is the one that you'll see next. Okay. So right now it's detecting obfuscation, and logically the final score is 81%. So it's higher because it also detected obfuscation, and that alone is also a sign of a skimmer. Not just because it was we found obfuscation, but this particular type of obfuscation, because some obfuscators are regularly used by skimmers, and obviously we look for those as well. So the results, the first one, the obfuscated version, is 66%. The obfuscated version, but only containing the skimmer, 81%. And we detected the obfuscation. It was used the SANEX obfuscator. And finally, if we analyze the full file, the grade was 85%, because by finding just a smaller part of the file is obfuscated and looks like a skimmer, it's more suspicious, and hence the higher score. Finally, we're looking at Caesar skimmer. It uses a different kind of obfuscation that you can see at the right. It's using Caesar plus obfuscation. It also has multi-page checkouts, but it uses local storage, not cookies, for that. So in order to work this example, we actually developed a Caesar plus deobfuscator that hopefully, if I have time, I will show you at the end. And the score was 86%, so it's higher than the previous examples that I've shown you. Mostly because the Caesar obfuscation is much more tied to malicious activity, to malware, and to web skimmers than SANEX. SANEX is somewhat tied, but there are some legitimate uses of SANEX sometimes. So if we look at the scores, all the samples that I've shown you, the grades, the final score was increasing in increasing order. So the one that is most likely a skimmer is the last one, but all of them were above the 50% threshold that we consider. So about testing, we collected 244 unique skimmers samples. So these are real MageCard skimmers. And also we collected JavaScript code from the top 1,000 Alexa, which resulted in 11,353 files. We pre-labeled the skimmer samples, ran the classifier through all the JavaScript files, and finally compare the score with the label and see if our estimation was accurate or not. We measured false positives, true positives, false negatives, and true negatives. And these are the results. So right now, using this data set, we managed to be 95% accurate. So it was actually pretty good for this data set. But we, and I think that the reason why is mostly connected with the fact that we are collecting a lot of diverse behaviors and not using signatures at all. So the final part of this presentation, and I think I'll have time for that, is present you the Brutus Minus, which is a deobfuscator for Caesar Plus that we have developed. So the Caesar Plus is available on the dark web for roughly $100. It's being used for all sorts of malware. And we analyzed, so initially we analyzed this this obfuscation. It basically has 2 layers of obfuscation. It uses a number of different string and integer obfuscations. You can see some examples. So you have a ternary operator, which is not really hard to digest. So it's very easy. Converts strings to base 34. Uses regex to clean somewhat obfuscated strings. So it's not that hard to remove this type of constructs, and it also injects that code. But the hardest part is dealing with the first layer. So the first layer that you can see here is actually encoded JavaScript. So I called it deciphering, but it's actually not using encryption. It's using encoding. So it self-decodes using eval. And then evaluates the results, and after that it gets the underlying code. The underlying code, the layer 2, also does a sort of anti-tampering. So it uses CRC checks to see whether or not we have removed the first layer. So using reflection. So you have to use some techniques to remove this layer 1 without triggering the CRC in the layer 2. And underneath you can see a lot of more number and string obfuscations, a lot of more dead code, etc. So final demonstration running the Brutus minus in this code. So this is a sample obfuscated with Caesar Plus. And here I'll run the Brutus minus on this sample. Okay, so I redirected the output to this file, brutus.js, and this is the output. So you can see the page allocation tests. You can still see some dead code running around, but it's not really preventing us from understanding what's happening. You see the query selector, the add event listeners. So it pretty much solves the problem for us. So in terms of classification, because we are able to do static analysis on the result without any issue whatsoever. You also see a lot of access to local storage. You see the drop server address. So there's a lot of things that you can see here, but generally it's not, we have everything pretty wide open to do our classification. All right. So wrapping up, web skimmers are increasingly more sophisticated. There's a lot I couldn't fit into this presentation. Some skimmers are using bot detection. Some skimmers are using stenography. Some skimmers are using sending data out as images. It's kind of a cat and mouse game. And the only way to approach this problem is by using behavior-based defenses, which is our approach. But it's not enough to block and control the behavior and enforce the behavior that one wants. It's also important to know what we are dealing with, and hence the work on this schema or mage card classifier. And we decided to build one. So we presented, it can work through layers of obfuscated codes. The results right now are very promising. You can either use the results straight out of this classifier or use it as a way to select candidates for deeper analysis, for even manual analysis if you want. It uses static code analysis, which scales very well. We are not running engines, we are not running browsers. So we don't have to deal with all of that confusion. We just need to run it against a large set of JavaScript files and look at the results. As a bonus, we presented Brutus minus, our Caesar plus the obfuscator. And that's it for now. We'll continue to work in this mage card classifier, and perhaps we'll see each other again in a follow-up presentation where we'll have more things to show. Thank you.
Thank you, Pedro. Thank you for your talk. Always good to know a little bit more on JavaScript attacks and how they appear. And as we are exposed daily to those problems, everyone buys things on the internet. So those attacks are on our list too. There are some questions, someone not understanding 100% how they inject malicious JavaScript. So if you can explain a little bit more. And another question coming from João Paulo that asks, are you considering to use different weights to analyze the different features that your product has, or if you already are doing that?
Mm-hmm. All right, the injection of the JavaScript is usually done by compromising a server. And usually, let's say it's a Magento server. Usually what they do is very unsophisticated attacks like brute forcing the admin password, or leveraging the fact that they are not running the latest version of the software and it has known vulnerabilities. So it actually, the mage cards, so the breach happens before the mage cards, and any way goes. So they, in spray and pray attacks, they are not after usually a specific server. They just try to breach as many servers as they can, and they inject the skimmer all at once in all targets and wait for the results. Second question, different weights. We are already using different weights for the different features. Right now, we are not adjusting these features or these weights automatically. This is one of the things that we'll work on using machine learning. But for now, it's working pretty good, at least using the data set that we have been testing.
Another small question, thank you for the answers. Another small question is that if the remote scan that you did detect the top 1,000 sites, is that code available, like in GitHub or so?
I don't think so. It's not available, but it's not. It's something that we can easily share because it's not very complicated code. I'm sure you will be able to find this type of codes on GitHub because there's lots of different tests that are done against Alexa top 1,000 or 10,000, etc. But after the talk with me, and we'll give you access to it.
Okay, thank you for your presentation again and for your time.